session on migrating to ES6. Before we get into this, just want to take an informal survey. How many folks are currently using ES6? See some hands. Okay, why are you here? So this is an introduction to ES6. We won't get into much advanced stuff. The other question is, folks using anything besides ES6, like let's say TypeScript? Anybody? A few folks. How about something a little bit more elaborate like ClojureScript? Anyone doing something? Right, so one hand in the back, one advanced JavaScript in the back. So what I want to start off this session with is discussing a little bit about why do we need to migrate to ES6 now as web developers. The main reason, in my opinion, is that with ES6 you can future-proof your code base today without having to wait for the browsers to catch up. And the main reason around that also is because ES6 is much better as a programming language than ES5. And it has stuff like modules, and we'll talk about arrow functions and other things like that. But it definitely is much better in terms of the overall language, putting together a nice maintainable code base and other things like that. And a common question, usually, especially for folks who are new to ES6 or new to the whole JavaScript thing, is, well, how do you use ES6 today if the browsers only support ES5, right? And the answer is simple, something called magic. Okay, no. It's actually, what we do is we do something called transpilation. So we use a tool like Babel, which will take our ES6 code and convert it so that it runs inside of any web browser, including Internet Explorer. Is anyone from Microsoft here? Okay, I can make some IE jokes on that. So takes your ES6 and transpiles it down to ES5 source code, basically what today's browsers support. And the process is relatively simple. You set up some tooling, i.e. you set up Babel. Nowadays with Babel 6, you also have to tell it specifically which set of ES6, ES7 features you want to include as part of the transpilation, and it spits out ES5 source code. It's fairly straightforward in terms of that. And there are other transpiled to JavaScript languages which are out there. Right? I already talked about one which is TypeScript. There's Dart, ClojureScript, PureScript. Right? There's loads of them. Now, one of the advantages of just using ES6, however, is that eventually you won't need the Babel transpiler. ES6 is the standard, so it will be in all the web browsers eventually. Right? So yeah, you can use ClojureScript, you can use TypeScript, any of the other different languages. So, am I not on? Try it. Yes, unplugged. Is that better? You're on. Okay, now I'm on. Thank you. All right, so if we look at the graph for what support is currently available out there, try to switch it up. I'll keep talking. So if you go look at the graph, and there's a link at the bottom, and the slides have been uploaded to the JFocus website, you'll see that the different browsers have varying level of support for the current ES6 feature set. Right? So this is a nice chart to go look at occasionally. Just wondering, what is the actual native support for ES6 inside of a browser? And I actually don't go look at this very much. Like I said, I just use Babel, and it converts everything into ES5, and I don't have to worry about anything. Right? I haven't run into any transpilation issues so far. Right? So now with the preliminary stuff set, let's take a quick tour of ES6. I'm going to talk even faster now because this is normally about a 90-minute or 2-hour session to get into all the different parts of ES6. You want to change this out? Yes. Okay. Can you hear me now? Yes. Okay. So one of the major things in ES6, which is really nice, is that finally in JavaScript we have support for real scopes. And this is a big deal because in the past what we've had to do as JavaScript developers is we've had to do basically code hacks to give us scope safety, right? And scopes have always been an issue in JavaScript. Finally, we have the ability to do proper scoping. And this is manifest in the form of 2 new keywords, specifically let and const. Right? What we can do with let and const is that it gives us block level scoping inside of JavaScript. And this is very important to have proper encapsulation within our code base. So what we do with this is, again, instead of using var, we use let to create a variable, and const, as you can imagine, is for creating a constant. So you can see on the last line there, if I try to reassign b to something else, it will fail. And in fact, what will happen currently is that you don't get a syntax error per se. The Babel transpiler will say you can't reassign a const to a new value. Okay. Now, let is scoped. It's also scoped at not just at the function level, but it's also scoped at the block level. So when we look at an if block, that let b equals 1 will be undefined outside of the scope. It's relatively straightforward. Same thing for a for loop. A lot of people get confused with this because a for loop is also considered to be a block. So when we have a for loop, we say let something, let I equals whatever. So inside that loop, that is defined, but outside it is not. Right? And similarly for constants, you can just create a random scope like this by just using curly braces if you wish to have some kind of scope. All right, so we'll move swiftly on to template strings. Template strings are also known as template literals in JavaScript. Now, what we can do with this, so we have a basic string which uses standard single quotes or double quotes. But what we do with template strings is that we use the backtick, right? The backtick is not the single quote. So we can create multi-line strings using the backtick, and also with the backtick, we can do string interpolation, i.e. template strings, or template literals, by doing something simple like this. And you see the last note on this slide is that you can actually even invoke a function inside of a template string. So you don't have to have that extra code where you assign a variable to some kind of function evaluation, and then you put that variable inside a template string. You can directly invoke a function inside of a template string, save a few lines of code, and make your code a little bit more expressive. Right? So that's about all we need to talk about in terms of template strings. Let's talk about core object functions for a while. Now, in ES6, they've added a whole bunch of stuff into several core objects. Let's do a quick flyby of that to help you understand how you can use these in your code base. So the first thing is they've added stuff to numbers. So now we have number is integer and number is not a number to verify that something is not a number. So how would you do this in the past, in ES5? What hoops do you have to jump through to be able to test that a number is really a number? What do you do? Anybody? What's that? You use jQuery. Okay, thank you. That's a great answer. So if you weren't using jQuery, how would you do this? How would you check to see if something that was filled in a form field is actually a number before you start doing stuff with it, so it doesn't blow up, basically? Right? Anybody? Right, you use parsing. You parse it, you see what comes out of it, and then it's a little bit of a hoop to jump through. So instead of doing that, what you can do is you can just say, number, is it an integer? Okay, it is. Now we can go on and write our code. Again, a lot of the migrating part is unlearning some of the habits that we have as ES5 developers and learning to use these new things so that we have more expressive code base. Right? They've also added some stuff to string, so you can check to see if a string includes something instead of having to use substring to check. Right? So this is kind of nice. It's syntactic sugar. You can also repeat a string like so. Right? So we have some utilities in strings and numbers. We've added a ton of stuff to arrays as well. So you can take an array and from a object or object literal, you can convert it into an array like so. Or you can use array.of and do 1, 2, 3. And what this will do is it will essentially convert a comma-separated list into a typed array. Okay, so this is very useful for a lot of different use cases. So think of something like a checkbox that you're trying to pull in from a form field, right? You can just say, here you go, right? Give me an array out of this. You don't have to jump through any additional hoops to be able to do this anymore, which is really nice. Right, and there are a ton of other things in the array API. You can fill an array. You can find stuff inside of an array now by using the .find. And if we look on this slide, you'll see that, and of course my pointer won't work properly now for some reason, but you can see that this thing that's happening inside of here, let me jump out of the editor for a second. Right, so if we look at this, let me make this smaller. It's so small. Right, so if we look at this find and find with index that we have here, you'll see that there's this strange new syntax here. These are essentially arrow functions, which we'll talk about in a few minutes. Okay? Arrow functions are a shorthand way of writing a function. So it does pretty much what a function declaration would do, but instead of writing out function, parentheses, x, et cetera, return x equals 3 to do a condition check here. What we can do is we can just substitute an arrow function so it gives us nice, terse, expressive way to write the same code without having a lot of boilerplate around it. Okay. So if you look at some of these other things, they're pretty self-explanatory. You can grab the keys, you can grab the values, et cetera, from different types of arrays that you may have. Now, one other thing that they've added that's interesting is they've added this dot assign inside of object. What a dot assign does is it essentially does a shallow copy, or maybe a better way of thinking of it is it does a shallow merge of two different object literals. So you can see in this example, I have an object with A:1, B:2, right? So I have three objects in here, and when I do object.assign from right to left, it merges those objects together and gives me one object, as you see in the comment line at the bottom. Okay? So this can be useful for merging different types of objects. Before, how we would do this is we would use underscore or lodash, and they have something in there that allows you to merge objects together. And we still end up using underscore lodash to do this because, again, this is a shallow merge. It is not a deep merge. So if we had something like A:, and then B: inside of it, or let's say X:, and then another object inside of it, if we had a nested object, it would not do a deep copy of it. Right? I'm not sure why they chose to do that, but I'm sure they have their reasons. All right. Now, one of my favorite parts of ES6 is something known as destructuring. This is essentially a way of getting to data inside of arrays and objects. And it's actually inspired by Clojure's destructuring. Right? If you're familiar with Clojure or ClojureScript, they have a nice API for doing destructuring of objects, right? Essentially reaching into objects and grabbing the data that you need. Right? What does this look like? Did I skip a slide? Yes, I did. Sorry about that. And of course, this is not going to work now for some reason. All right. So this is a very simple example of a destructure, where what we can do is we can access an array and swap the values like so if we wanted to. So bar becomes foo and foo becomes bar in this case. Let's look at another quick example that's very simple. We have a point object. Point X is something, Y is something. Now what we want to do is we want to pull those things out, and we want to have them as locally scoped variables. So what we can do in this case is we can say var, curly brace, X, Y equals that object, and it reaches into that point object or PT object and materializes those as local variables. Okay? And I don't have to use a var in front of this. I could use a let if I wanted to, or I could use a const if I wanted to. But the key here with the syntax is that we use the curly braces at the front, and it infers from the name that we have as the curly brace as to which thing on the inside of that object we want to essentially move up into the current scope. Okay. So here's another example of destructuring. This is a slightly more complicated example. Here you can see we have a nested data structure where we have data : and then X : Y:. Okay, those are our keys. Data is the outermost key, and then the inner keys are X and Y. And so what we can do here is we can say let data : X, Y equals point. And again, what we get is we get X and Y with the appropriate value that was on the inside of that object. Okay. So this is fairly straightforward. Now, you might be thinking, when is this actually handy? Why is destructuring one of my favorite things in ES6? Let me show you a quick project. And there is a, let me find the right one. Of course, I won't be able to find it because you're watching me. Okay, here we go. All right, so let's go. This is a React application that we're building. How many folks are doing stuff with React, just out of curiosity? Out of those people using React right now, are you doing it ES5 or ES6 style? How many people are doing ES6 in React? All right, pretty much the same folks. All right, just curious to see what folks were using. All right, so if we look at this, here right at the top is an example of destructuring, where we say import all of these things from the React Bootstrap library. So the way that we would normally write this is we would say import, right, jumbotron, from React-Bootstrap. And then we would write import, oops, not that one. And my copy paste abilities are not working properly today. Okay? Then we would say this. And then we would say, sorry about this, right? We would list everything out like this. And you can see that this becomes very verbose very quickly, because we want to import all these different components from our React UI library. So instead of doing all that crap, what we do is we take all that out, and we put it all in one line. It's very expressive, but it's not convoluted. Anyone can read this and instantly figure out what's going, as long as you understand that destructuring is happening in this specific example. All right, so let's talk about modules for a bit. Now, modular JavaScript has been around for a while, but unfortunately in ES5 what we've had to do is we've had to do some tricks, or hacks, or some people may call them best practices, right? And some of those kind of patterns that we follow for doing popular modular JavaScript in the browser, for example, is the revealing module pattern. There's also the dependency injection module pattern, and there's the exposing module pattern. There's all these different patterns that we've had to apply to get proper scope safety and encapsulation within our JavaScript projects once our code base becomes sufficiently large and we need organization around it. So it's been around for a while, but we've been doing these hacks or tricks or best practices or whatever you want to call them to be able to achieve this. Right, fortunately now in ES6 we have a real way to do modules, right? So we've kind of leapt forward and backwards in time. So if you build stuff in Node.js on the server, they've been using something called common.js, and that is essentially a module type pattern, or it's an implementation of a module syntax and stuff around it for a while. And again, we've been using the module pattern, which is something we wrap in an IIFE to do this. Right, so in the past, what we've done is we've used an IIFE, or immediately invoked function execution pattern, to be able to get encapsulation and scope safety. Right, and we use tools like Browserify, AMD, and if you're writing stuff on the server, common.js to do this. Right, fortunately now, we don't have to worry about this. Right? Node has supported modules for a while in the common.js format, and we can package stuff into Node or NPM modules that we can also run in the browser using a tool like Browserify or Webpack. Right? It goes and gets everything ready for us, so we don't have to do it. But in the new version of JavaScript, well, let's look at the old version first, right? So this is an example of a revealing module pattern. You can see we have an IIFE here, an immediately invoked function execution, which gives us that encapsulation and scope safety that we need to be able to properly write a large modular JavaScript-based project. Right? But that's the past. Right? Also in the past, or maybe even currently, if we were using common.js style stuff running in Node on the server, we would do something like exports.message in our message.js file. And when we wanted to consume it, we would say, go and require that specific thing, .message, which is the specific export that we want. Okay, and then we can use that thing that we have in the module over here. So what we can do now is we have a few new things. We have syntax like this that we can use, where we can say we have something in our message.js file that's export constant message equals hello Babel or something. And then somewhere else we can go and pull that thing in by just doing import message from .message. Right? You can see there's no .js there anymore. So this is one way we could do it. Right? We could also look at this more complete example where we have something called libs/math.js. And in there we have a couple of things that we want to expose to the outside world. On the second line you see we have export function sum, and then just below that we have export variable pi equals this. And then when we want to use that, we could pull everything into scope by doing something like this, where we use a wildcard and we say import star as math from lib/math, and then we get math.sum, math.pi, etc. Okay, or we can use destructuring here so that we don't need to keep that annoying math reference in our code base, and we can just destructure this immediately and say import curly brace sum, comma pi from the math library, and then those variables will become in scope so that we can use them. Okay. So this is the future of modules. This is yet another variation of this. Right? In ES6 we can also do something like this where we say the default exports from this module should be this thing. So you can see there's export default about halfway down, and what we do is we map things that we specifically wish to expose to the outside world with key value pairs, and then we can just simply go import message from that module and start using it. Okay, so there are a couple of different ways that we can slice this. There is essentially no correct way, but we have some options in terms of how we want to structure our modules. Okay. Now, one thing about modules that some folks don't realize when they come into the ES6 world is that modules are stateful. That means that if you import a module over here in your code base and you import a module over here in your code base, they both are the same module. They're the same instance of the module, to be very specific. Right? So what does that mean? Let's have a look at another example in code to kind of help you understand what the implications of that are. Right? So I have a module here. It's called Rails authorization.js. Here's my module.exports, and I'm exporting login, I'm exporting get token, logout, logged in, et cetera, right? So you get the idea. This is a basic login module for logging into some backend service currently hard-coded to run on port 3000. Okay? Just making an API call to log the user in with their email and password. Right? I'm sure everybody has this in some form in their code. All right? So the question is if I hit login over here, and in some other place I need to go grab the authentication token to make a call back to my server, right? Once I've logged in, I take that auth token and I need to store it somewhere so that later I can use the auth token to make subsequent requests to my API. So if we look at this, you'll see that I'm storing the auth token up here somewhere, right? So I store the auth token, and then I simply have another exposed function called getToken that returns the auth token. So what that means is I can log in over here in my login panel or login.js, and then over here where I have report.js, I can say, okay, go and get the library that we use for authentication. I'm going to kind of complete the picture on this. Right? You may have noticed that I imported auth from this guy earlier. Right? But what this does is this keeps a single stateful copy of the module in our system. So if I go import it in a number of different places, it will not be different copies of it. It will always be one instance. Okay? It's just something to bear in mind as you are working and building your own service modules and service objects for use in your code base. All right. So let's talk about object literals for a few minutes. They've made some improvements to object literals which make it a little bit easier to work with and create object literals. So specifically, we're able to set the prototype at construction time. Right, so if you've done object-oriented JavaScript, you probably have felt the pain of doing prototypical kind of inheritance. You have to go and set the proto, and it's a big mess. Right? And there's also shorthand for assignments. Let's look at this in code, see what it looks like in just a second. We also have the ability to have defined methods, things that look like methods. They're still functions, obviously. We can access the super, and we can also have computed property names rather than having to have hard-coded property names. Right, so let's look at this in code and see what it actually looks like. I'm pretending myself up here. All right, so if we look at this example, and I'm going to untangle myself here, you can see that on the third line here, we have direct access to the prototype. Well, I guess underscore isn't supposed to really be direct access, right? In JavaScript, underscore means that it's supposed to be a hidden variable. But as we all know, JavaScript is a completely open language. You can change anything in the language at any point in time. So anyways, you have access to the proto here. So what we can do is we can go set the prototype or the parent object if we want, right? What would we have to do before we had to go to do this? We would basically have to unwrap the object and go and set it manually afterwards or some stupid crap like that. And there were several patterns that we would use to be able to do something very simple like this. One of them that comes to mind that we've used in the past is the parasitic inheritance or parasitic prototype inheritance pattern, right? So we no longer have to do this crap. We can just say, okay, this is the parent. And another nice thing is if you have something like on line number 4 where we say handler : handler, we don't need to have the verbosity of doing this anymore. We can just say handler, comma, and it assumes that the right side will have the same name as what we have on the left side. So we can just say handler instead of handler : handler. And we can also have things that look like methods. So there's a toString in here. You can see it basically is a function. So we can just say toString or whatever function we wish to include is part of this object literal. And one of the interesting things that they've added is on the last line, which is a computed property name. So you can actually dynamically create properties property names if you want at this point in time in JavaScript. So the reason why this is interesting, we don't really use this much, to be honest with you. I don't think we've ever used this. But the reason why this is interesting is that this opens the door to doing advanced metaprogramming techniques within our JavaScript code base. Okay? I'm not suggesting that you should do metaprogramming in your code base, but if you need to do something very advanced, you have the access to do kind of rudimentary metaprogramming by having dynamic property names set. Okay? And they're looking at the support for full metaprogramming in future versions of JavaScript. Essentially, if you're familiar with Ruby's method missing, which allows you to just have any arbitrary function call on an object, they're looking at that in the future. But we'll see if that actually makes it into the spec or not. I hope it doesn't, because I personally don't like the magic of metaprogramming, but that's just me. That's just my opinion rather than fact. All right, so let's continue our tour now and talk some about function parameters. We finally have the ability to do real default values in JavaScript, and we have proper support for var args now. Right, this is excellent. Both these are very useful in day-to-day programming. All right, so what does parameters mean? Or what do the default parameters look like? It's very simple. Function x, comma, y equals 12. So if y is not defined, and as you can see on the last line, we say call the function with one parameter of 3, it will actually return as 15, because it will use 12 as the default value of y in case it is not set. Okay. So now a common question here, and I'm going to jump out of this real quick. Common question here is, what if, and let me just comment this crap out. Now, what if we pass an undefined as the second argument? What do you think we'll get? We pass it undefined as y rather than nothing. So if we run this right now, let's clean this up a little bit and do console.log of f of 3, right? And you can see down here on the bottom, right here, we get 15, okay? Now what do you think is going to happen if I set this to be a null? We still get 15, or will we get an error? Right. So in this case, we have some math wizardry going on. It actually gives us the number 3, right? If you look again down here at the bottom one, 3. But let's see what happens if we send in an undefined. Okay, now we get 15. Well, this is interesting. What the hell just happened there? Right. So if I have undefined, I get 15. If I put a null in here, I get a 3. Right? So you can see 15 and 3. Okay. So unfortunately, one of the things that's always frustrating about working in JavaScript is that there are a lot of edge cases that we have to look out for, right? In the old versions of JavaScript before let, what we had to do is we had to accommodate for the hoisting problem, right? We would hoist all our variables up to the top of the scope to avoid a certain class of bugs, right? We would use triple equals. Actually, you still need to use triple equals to make sure that you do proper comparisons, right? There are lots of little things as a developer we have to keep in our brain when we're writing JavaScript code. And it would be nice to not have to remember all those things and just focus on the business problem I'm trying to solve. But unfortunately, even with the ES6, there are a couple of small nuances like this which can bite you, right? Because there's a distinct possibility that when we call this function, if we get an undefined, okay, this is what we expect. We expect that it will just use the default. But there are times where we may actually get a null, and we may invoke this with a null for some reason. But instead of getting 15, we get a 3. Just be aware there are a couple of little things that you have to get used to. They haven't completely ironed out all the rough edges. Hopefully, obviously, JavaScript will get better over time as ES2015 or ES7 comes out. But just be aware of these kind of little things as you dive into the ES6 world. Now, one thing that has always been a little bit of a sore spot is the very attic support in JavaScript with the arguments keyword, right? What is the arguments keyword in JavaScript? Right? When you call a function, it's basically what all the arguments get stuffed into. But the problem is instead of being, oh, I don't know, something like an array, which makes sense, they made it a object literal, right? So, just show you a quick example of that. If I can do it quickly, I will. Right, so let's fire up Node. And if we say something like function sure if this will work, but I'll try it. Okay, so actually let's do this. Let's pass in just an arbitrary number of things. All right, so you can see what I did is I just did a console.log here of that arguments keyword that just goes, that has all of our arguments irregardless of the number of actual arguments passed in. And so why the hell is it giving me a object literal? Can I please just get an array? Can we make life easier, right? Thankfully, that's what they've done in ES6. Instead of arguments, you have access to args now, okay? To make it sufficiently confusing. So what we can do now is using something called the REST operator, the triple dots here, we can say function ... args, and then that args is actually an array, okay? So it makes writing code or functions that need variadic support much nicer, right? So along with the REST operator, the other side of that coin is so the REST is in the function signature, as you can see here. The spread operator is the other side of that coin. So in the spread operator, what we do is it allows us to turn an array into consecutive arguments, and essentially is a better way of doing var args. So what we can do, and this is often the case where we have multiple things that we need to pass in, the spread operator will unwrap that for us and get it ready to be consumed by a REST on the other side. Right? What does that look like? We'll go back to our previous example, and this is the complete example now. You can see we have the REST args at the top. We have an array, and then we want to call that on the way going into the function. We say sum ... my array, and it unwraps that so it looks like what we have there at in the line that's commented out, right? So it's the equivalent of calling sum 1, 2, 3, 4, etc. Okay. So this is really nice for cases where you need to use variadics. All right. So now let's talk about arrow functions. This is probably the single largest enhancement that we have in ES6. Arrow functions are essentially shorthand for doing the, anyone get the reference to Mr. Fusion here? Like Back to the Future, right? So arrow functions are a way of doing concise function inline or declared function declaration, right? So what this looks like, in just a second, talk a little bit more about that. The arrow functions are essentially syntactic sugar for declaring functions. It's terser syntax, but there's one key thing that we need to look out for. Right? So if we just look at a simple example of an arrow function, set timeout is a standard browser function, which you're aware of. And how we would do this in ES5 is we would say function console.log, and then you can see that basically we have an inline function inside of that function call, right? Which is a very common thing to do in JavaScript, especially when we're doing callbacks and other things like that. Now, how we would write that in ES6 is on the last line here. You can see there's an open close parens, there's something that looks like an arrow, and then the body of the function. Right? So it's syntactic sugar that allows us to more concisely express a function using slightly more terse syntax. Actually, we can make this even smaller in just a second. So here's the same function written 3 times. The first one you guys probably can understand because it's standard ES5 function declaration. The second one, var square equals x arrow and then my function body. In fact, what we can do here is, because this is such a simple function and we're just returning something at the end, what we can actually do is we can take out these parentheses here, we can take out the open close curly brace, we can take out the return, and then we are simply left with the x, which is this guy here, the arrow, which is our arrow function declaration syntax, and then the guts, or the body of the function, which is just x times x. Right? So this is kind of nice. We've reduced a bunch of lines of, or a bunch of characters of code into smaller, more expressive code. Okay? And you probably heard me use this word expressive a lot so far. This is one of the nice things about ES6, is that it's not like Perl, where you write some code and it's so dense and and so difficult to understand that you have no idea what you wrote 5 minutes ago sometimes, right? Do we have any Perl hackers in here? Before, okay. With apologies to the one Perl hacker in here. One of the things I never liked about Perl was that the language was very expressive, but it was very easy to make code that was very obfuscated, right? You wrote some code a week ago, you come back to it and you're like, what the hell did I write? I don't even understand what this is anymore, right? So there's a difference between having compressed code that is kind of obfuscated and difficult to understand, as opposed to having expressive code, which is shorter but as easy as the developer to understand. And the reason why we care about this, number one, I don't really care about the number of characters I have to type to write code, right? Unless it's like in some very, very verbose language, Java. Right, so I don't really care about the number of lines I have to write. What I really care about is, can I write this in a way that's very expressive, but also readable and maintainable over time? And this is what arrow functions, in my opinion, give us in the JavaScript world. Okay. All right. So let's get into this a little bit more. There is one key difference between arrow functions and a standard function declaration when you use the function keyword, i.e. the thing that first declaration on this slide, or in this slide. There's a big difference between the first and the second two. And that is that this that we have in JavaScript is bound to the evaluation scope and not the runtime scope. Obviously it's shorter, but again, the keyword this is bound at the evaluation scope versus the runtime scope. Now, how many people understand what I just said? I don't even understand it. Okay, some people do. Thank you. Good. That means I've done a good job of trying to explain it. But for the other half of your people who didn't raise your hands, what I'd like to do is I'd like to do a quick code example to show you in code exactly what this looks like. And I prefer to look at code examples rather than have someone like try to explain it to me, because oftentimes it's just easier just to say, just show me the code, show me what it does, right? So what I have here, we have an array here with some names, and let's do the ES5 style version first, which is here at the bottom. Can you guys read this in the back? Is this big enough? Yeah. Okay, thank you. All right, so I'll make it a little bit bigger. Okay. So what we'll do here is we have a JavaScript object literal. We have a function inside of it called greetFriends, function friends, for each of those friends, do console.log this.name. And you guys have probably run into this before if you've ever written a callback of any kind, which obviously you have. But you can see what the output is, right? The output at the bottom, it says, cannot read property name of undefined. Okay? What have we done wrong here? This looks like it should work. What's the problem here? It's that we don't have lexical scoping when we use a standard ES5 function declaration. We do not have lexical scoping. Lexical scoping means that we bind at the evaluation level rather than at the runtime level the context in which a specific function is supposed to work, right? So what will we do to fix this? How can we fix this to make this work? What do you think? This is an easy question. The trick questions come later. So get your answers in now. What do you think? What's that? Friend instead of this. Yeah, but how do you know which position you're in if you do that?
Maybe just change left to var.
Change left to var. No, that won't actually help us, right? Because the function, this is the problem area. Everything around it is fine.
Create a new variable and assign this to that variable.
Thank you. So the answer is we set that equal to this. And what I mean by that is literally we're going to say set that equal to this. Okay? So we'll take that, we'll put this here, and you can see it works now. Okay? You've probably done this in some variation hundreds of times before in your JavaScript code. Or maybe you've read some JavaScript code like, why are they doing that? It's because, again, the context is bound at runtime rather than at declaration or definition time, evaluation time, okay? So when we think of JavaScript, JavaScript has two distinct phases when we are executing some code. The first phase of JavaScript execution is it takes all the characters we have in this JS file and it produces an abstract syntax tree from it. It takes that abstract syntax tree, passes it to the second phase, which is the execution phase. So we have two distinct phases in JavaScript, right? Pretty much every scripting language will have those two distinct phases. Now, when the JavaScript interpreter looks at this, it doesn't do anything special to set the context of the function until we are executing it. So when we use an arrow function, what we'll do is, again, we'll say, let me comment this in so you can see it. Okay? So what we'll do is we'll say friends for each, right? It's exactly like before. You can see here from the syntax highlighting. Oops, why did I do that? I don't like the dictionary. Okay? So you can see here's friends for each. It's exactly the same, standard loop around an array, but we're using an arrow function here. Here's my parameter, here's my arrow, the contents of this, but you can see that I don't have a this equals that here, but my code still works, right? So let me just comment that out. You can see that there's nothing running. Now if I run this, you can see it works. So what happens in an arrow function is that the this gets bound at declaration time. So you don't have to do that equals this. It happens at that specific place. Okay. Now, this can be a little bit of an issue if you actually want to have runtime scoping. Okay. Typically, though, when we write JavaScript code, we want the context to be set in the area in which that function was declared, rather than at runtime, right? Because that's why we tend to do a lot of this equals that. Okay. So hopefully, this code example illustrated clearly what the major difference between arrows and standard ES5 functions are. It's the context, i.e. the this, that we're concerned about. Okay. All right. So we have 10 minutes. I'm not going to talk about everything that's left here, because there's a lot of stuff in ES6. But real classes are finally here in JavaScript. Yay! It's amazing. So obviously, you even with my American English, you probably detected some sarcasm in that, right? So, for all the JavaScript that we write, we have a ton of JavaScript. We do not do object-oriented JavaScript. We started down that road. We said, yes, let's do prototypical inheritance. It's going to be fun. Let's use the parasitic inheritance design pattern. It's going to be fun. It'll work great. Well, what we eventually found out was that doing object-oriented OOP in JavaScript, especially in ES5 with parasitic inheritance and other hoops you have to jump through, actually led to brittle, unmaintainable code. So the way that we write JavaScript, and obviously after years and years of doing this, you kind of get better at whatever it is you're doing. What we do now is we almost exclusively write functional programming style JavaScript. We do not do object-oriented JavaScript. That is my opinion. There are some people who love object-oriented JavaScript and they think it's great, especially with the new stuff that we have in ES6. What we can do in ES6, right? Okay, so this is an ES5 example, right? So this is the old way of doing classes in JavaScript. You can see that we do person.prototype, et cetera, et cetera. But this is much nicer in ES6. We can say class, so there's a new keyword called class here. We have a new constructor keyword where we throw in some constructor stuff, and then you can see we just define our methods and properties as we wish directly in here, and then we can new this guy up, okay? Or new Alice up in this case. So this is how we do classes, and it is much better than it used to be. And not only can we just create a class, we can also extend a class. So we can say class X extends Y, right? Most of you are probably Java programmers in here, so you probably are familiar with the class and extends keywords and exactly what that means, okay? So you can see there's also the super keyword to be able to invoke a super or invoke the parent in some way, right? So there's some frameworks, especially when we do React, and you probably saw in my React code that yes, we still have a little bit of, right? So here's class, login extends React component. But you're like, dude, you just said that you try to do functional programming in JavaScript as much as possible. But unfortunately, some of the frameworks, specifically React and ES6 style and Ember, still rely very heavily underneath the hood, or when you consume it as a developer, on object-oriented interfaces into their API, right? So what we try to do, to be honest with you, is we try to minimize the number of object-oriented, minimize the amount of OOP we do in our JavaScript code base, and we try to do the complex business logic-y stuff using functional programming techniques. Okay. And if you want to hear a much longer diatribe of that, I'll be getting beer later this afternoon or this evening down at the happy hour. What time's the happy hour today? All right, I'll be at the bar at 5 if you want to talk. This is my last session for the conference. So let's talk about some new data structures very quickly. They added the set data structure in ES6. This is nice that they're adding these kind of nice data structures. It helps with creating a more sophisticated code base rather than having to use object literals for everything, okay, or arrays. So you can see that here's a quick example of how you can create a set in JavaScript or ES6. Okay, they added another really nice thing, and we've been using this a lot, called map. So what we did in the past is we would just use an object literal as a map. An object literal is pretty much a map, right? But we actually have real maps now. This is excellent, right? Now we're making some progress, right? Because I want to have these sophisticated, low-level data structures as I go and build up my JavaScript code base, so I express in my code exactly what my intent is when I'm trying to solve a problem. Right? So having these data structures is very handy. All right? And there are more data structures that they've added. We won't really go into them too much. There's weakmap and set. This is typically not useful for your normal JavaScript developer. We've never used a weakmap or weakset in our code base, so I don't really want to talk too much about that. We're just going to skip over the code demo of that. We'll skip over it now. And one of the interesting things is that JavaScript has promises baked into the language now. Promises are very useful in an asynchronous programming language, and all of you probably know by now that JavaScript is an inherently single-threaded asynchronous programming language. So it's about time we got promises to help us manage the asynchronous code we have in our code base. Right? What does the promise look like? Use a very simple example. We create a new promise. We pass it two keywords, or two things, resolve and reject. Right? Resolve means that the promise resolved to that specific phase. Reject means that something happened and it failed. And you can see how we use this then. We say in our timeout, create the timeout. My pointer is dying very quickly here. And then we say, then go do this thing, then go do this thing. If something happens along the way, dot catch the error and tell us that the promise failed in some way or whatever. Okay? But the key here is that we have the ability to do promises. If I had more time, I would do a more complex example of this. But this is definitely something worth exploring inside of JavaScript. Okay. Is the next speaker here yet? Okay, good. I'm going to keep going until he shows up. Is that okay? All right. So, a couple of things I want to mention quickly. In ES6, there are these things called generators that allow you to write very specific types of code for building what we would call them in the functional programming parlance is building monadic structures to allow us to do kind of sequential processing based on different types of business rules. Right? In the time that we've been using ES6, I've never had the need to use a generator. Generators are more for people who are building frameworks and doing like very low-level advanced things. So we generally never even think that we need to use them. We're able to solve our problems without having to dive into generators. Right? So I'm not even going to talk about them here. You can look at them if you're bored, but we don't find, in my opinion, we don't personally believe that they're very useful for your kind of normal coding, building a web application or whatever it may be. If you're building a framework, I can see how it would be useful. Symbols are a new primitive type. Symbols, as you can imagine, are exactly like symbols in other programming language. They allow you to set a new symbol within your code base. Obviously, symbols are unique. Let's just look at a quick example. And you can see that in this example, the third line down, we say var key equals, and there's the new keyword there, symbol, equals key. And then what we can do is we can use that symbol in various different places to do a lookup, as we see in a couple of different places here. And we can kind of get a way of creating our own unique ways of describing certain types of keys and other kind of low-level programming constructs. We don't really use symbols either, to be honest with you. I can see how they'd be handy, but we don't really need them, right? At least for us. Okay. I'm at time, okay. I told you I'm gonna keep going until the other guys say that. No, I'm just kidding. I'll try to wrap this up in the next 60 seconds. So, we'll skip over, computer properties for now. Okay. Well, what I wanna end on, and then there's also iterable. I'm just gonna have to jump ahead here. Okay. So one place that symbols are useful, for example, is, when we do iterables and for-ofs, like so. Right, you can see right here we have symbol.iterator. But again, I'm at time, so I'm going to skip over that. What I want to spend the last 60 seconds talking about is stuff we didn't cover. I didn't talk about unicode. There's also this thing called proxies in ES6. Again, my opinion on proxies is that it's more of an advanced feature that your typical developer will not need to use. Okay? But obviously it's worth looking at them. You might find them useful. Binary and octal literals, again, some low-level stuff. There's a reflection API, which is very interesting. Again, I believe that something like that is more suited for framework builders. And unfortunately, we didn't have time to talk about tail call and tail call recursion, but that goes along with lazy evaluation. All right. So the other stuff we didn't talk about is the new stuff that's coming in ES2016. But that is probably another hour talk on top of this. So here's a reference. The slides have been uploaded to the website if you would like to browse them. And I thank you for coming, and I hope you enjoy the rest of the conference.